This is GATE 2016 Set 2 EC question number 23. A uniform and constant magnetic field B vector is BZ hat exists in the Z direction in vacuum. Particle of mass m and small charge q is introduced in this region with an initial velocity of v vector equal to vx x hat plus vz z hat. Given that B, M, Q, Vx and Vz are non-zero, which of the following describes the eventual trajectory of the particle, whether it will be helical, circular, linear motion, and in which direction? So as per the question, we need to know one thing. Lorentz force, that is the force experienced by a charge which is F vector, which is moving under the influence of a magnetic field, is given by F equal to Q V cross B. So if a charge particle, let's say Q, is moving with some velocity under some influence of some magnetic field, say B. So V cross B, the force will be FB. Let's say this is FB, because F due to this B vector, so FB, it will experience some force. Now, in the given question, B is in the Z direction and its magnitude is B, and in the positive Z direction. So like this, this is out of the board, so it is in positive Z direction. So this is B like this, and what is done, the particle under consideration is left in this magnetic field with velocity. Let's say this is the particle and the velocity of the particle is Vx x hat plus Vz z hat. Now you similarly, if the charge is small charge is q plus q and the velocity is this, then same you do, force is q v cross b, and you find the charge on this particle. Okay, coming to the solution. So now continuing, force on the charged particle is F q v cross b. Now v is q vx cross b, where b, because vz cross b will be 0 because both are in z direction. So the force will be 0 for the z component of the velocity, and only x component will contribute. Now in x component, the magnitude is Vx and this is B. So x cross z, right, you can see x, y, z. X cross z is minus y, so this in the minus y direction it will face a force. Now after facing this force, the particle is here. Now see what is the situation. We have this coordinate axis and this is x, this is y, this is z in the right hand circular system. Now if the particle is somewhere here, it has a x component of velocity and a z component of velocity, right? And the force on the particle is always in the FB is always in the y-axis, because for this component of velocity there is no force due to this velocity, because this velocity is not perpendicular to the existing magnetic field. So the existing magnetic field is like this in the z direction, in the positive z direction. Since there is magnetic field parallel to this component of velocity, so this component of velocity will remain undistorted as there is no force, and force is always in the minus y direction. So this velocity Vx will change. So what will happen, that this velocity Vx and this component of force will result in a motion in this direction, resultant that is. Then the particle will come here and the velocity will be somewhat tangent to this, right? Because acceleration will be in this direction and velocity in this direction, so the velocity changes in its direction but not its magnitude. So Vx is like this. Again, since the velocity is like this, but it is not now in the x direction, but this cross the magnetic field which is in this direction will again result in, will be like this. Again the particle may come here and its velocity is now like this is Vx. Then again the force will be this. So a circular motion will be executed in the xy plane, and this particle also has a velocity in the z direction which is undistorted. So what will happen, the particle will exhibit circular motion and move in the z direction also. So it will advance like this, like the motion shown in this sense. So it will execute helical motion. Option A is the correct option. The particle will execute helical motion in the positive z direction.